In the previous video, we started to talk about um, cell arrays, right? And uh, it's a quite powerful data structure provided by Matlab. And what I was saying is that it's a heterogeneous type of composite container. Right? It's a type of composite heterogeneous composite container, which means that the smaller containers inside of those inside of a cell array can be of different type. They can hold different kinds of data. Right? And the approach that we used for introducing cell array is actually exactly the same as how we actually introduced matrices and vectors, right? So we started to talk about how to actually construct cell arrays or create cell arrays, right? Using different approaches, right? Um, and when we talked about matrices and vectors, we also started to talk about. We also started with talking about how to construct matrices and vectors using some built-in functions provided by Matlab, right? So, so, so here we are talking about different ways for constructing a cell array, right? I sort of reorganized the scripts a little bit, right? So it may look slightly different from the script that I was working on in the previous video, uh, but the content is about the same. So there might be some differences, one line or here, um, and some differences in terms of the comments, right? But the actual codes are pretty much the same, right? And then constructing the cell array is just the first step, right? You are putting data into this particular container, this particular type of container, right? And then a second step is that you want to retrieve data from this kind of data structure, right? That involves indexing. And we started to talk about indexing. We talked about how do we actually um, uh, do cell indexing and how do we actually do content indexing. For cell array, there are two types of indexing, right? But for matrices and vectors, there's just one type of indexing, which is provided by the smooth parentheses, right? Um, but for cell array, you have two different kinds of indexing. The cell indexing, if you use the smooth parentheses, you're doing the cell indexing, which means that you are retrieving a particular cell or particular set of cells out of a cell array. A cell is just a wrapper. It's just a kind of wrapper container around other different kinds of containers, right? So any kind of thing, string, double, character, or matrices or vectors, any kind of data structure can be put into a cell wrapper, right? And that cell wrapper can be one component of or one element of a particular cell array. So by doing this kind of smooth parenthesis indexing, you're doing the so-called cell indexing, right? So you're retrieving that particular cell out of that cell array. And then if you use curly brackets, which is called content indexing, which means that you are not exactly interested in the entire wrapped cell, right? You're not interested in retrieving the cell wrapper, right? You want to actually take out the content that's inside of that particular cell. So here we're particularly interested in the cell that's first row and first column, right? But we're not trying to actually get the cell itself. We're trying to get the content inside that cell. So we're using curly brackets, right? And the Matlab function class allows us to actually examine what's actually the type of that particular cell. Of the input, right? So here, if you do this, if you execute this particular line, Matlab is going to print out the cell because this is indeed a cell, right? You are retrieving a cell out of a cell array. But if you actually do this thing using these curly brackets, right? Then Matlab is going to print out either double or something, right? So C0, it's a char, right? So C011, that's supposed to be a char, right? So Matlab function, this class function, it's the internal class function is going to tell you what's actually the data type of the input, right? So there's this kind of distinction for cell array that's something that we have to remember, right? And then once we have understood this kind of a particular distinction, we can actually use it to our advantage. Suppose you have constructed some kind of table for medical records of different patients, and each patient occupies one row in this particular cell array, right? So here we're actually constructing the cell array, right? So you have to pay attention to the right hand side and left hand side, right? So the left hand side is using smooth parentheses, right? Which means that we're retrieving a cell out of this records cell array, right? So it's not just one cell, it's actually a whole row of cells, right? It's the first row of this particular cell array, but we're retrieving it as cells. We're not retrieving it as content, right? So here on the right hand side we have to assign a cell array to it, right? The left hand side and right hand side must have exactly the same type. So how do we actually put together a cell array and assign it to it, to the left hand side, right? We use curly brackets here, right? So we have to wrap everything inside of a curly brackets to convert this content. The content is highlighted in here, right? That's the content. To convert this content into a cell array and then do the assignment. Otherwise, you're gonna have a type mismatch because the container that's on the left hand side has different type from what you are assigning it to, right? From the stuff that you are actually assigning it to. So that's for one patient, Kelly, right? That's for a second patient, Mark. The third patient, Susan, right? And then here we're actually changing the third row, first column, right? But we're changing it. But on the left hand side, we're still actually doing it as a cell indexing, right? It's because smooth parentheses. So on the right hand side, we have to assign a cell to it. So even though what we want to do is to just change the name, which is a char, right? But we have to wrap the char inside of the curly brackets to convert it into a cell, to convert it into a cell before we do the assignment. Otherwise, it's not going to work, right? But if you don't want to do this kind of curly brackets wrapping, what you can do is to convert the left-hand side from the cell indexing to content indexing, right? To use curly brackets. Right? If you use curly brackets, then Matlab is going to retrieve the content of that particular cell, which is a char, right? And then you can assign a char to it. Right, so the right hand side again matches with the left hand side, right? And then if you want to sort of delete a particular row or delete a particular column, all you have to do is to do this kind of cell indexing for the row and for the column, and then assign this empty square bracket to it, right? So in Matlab, this kind of empty square bracket means nothing, right? It represents nothing. You assign empty nothing into this particular row, nothing into this particular column, which is equivalent to deleting a particular row or a particular column, right? And then how do we actually do this kind of a nested indexing, right? So if you look at the medical record, it's actually nested cell arrays, right? So the whole thing is a cell array, right? And then inside of it, one of those components, one of the elements is again another cell array, right? And then inside of this particular inner cell array, you have a matrix that's as one of those components of the inner cell array, right? So how do we actually index into this kind of a hierarchical structure, right? This kind of nested structure. So here we're actually trying to print out the name and the two blood pressures, right? The two blood pressures are actually stored in this integer vector with two numbers, right? So how are we going to do that? Right? The name is kind of easy, right? Because it's just the first column, right? If we want to print out the second patient, which is because we deleted one row, right? So here we deleted one row, so the first patient becomes Mark, right? But don't forget this kind of a fprintf. This is actually borrowed from C language, right? So these kind of a space holders actually corresponds to the content of a cell array. It's not really corresponding to the cell itself. It corresponds to the content of that particular cell. So here you have to use curly brackets to unwrap that particular cell to actually retrieve the content. And then this is going to be mapped to this %s, which means a string space holder, right? %s is a string space holder, so you have to give it a string. So this one corresponds to this one, right? And then you will need two integers. %d means integer. These are space holders for integers. You're going to need two integers, right? You're going to need two integers. The two blood pressure is this particular vector, right? So how do you actually access this particular vector, right? So first of all, you have to sort of make sure that you can access this particular cell array, this nested cell array, right? Um, so it's the second row. So the first row is deleted. So the second row is going to be Susan, right? Susan. So the name is supposed to be Susan, and then you are supposed to actually get to this particular cell array first, right? This cell array is what? This is the cell array is the second row, third column of the outer cell array, right? So why it's second row, second column? Oh, because I have deleted one column here, right? I delete the second column, so this column has disappeared, right? So that's the first column, and then after I delete the second column, this becomes the second column, right? So that's why it's a 2 here, right? So in order to actually get to this particular cell array, I need to do a content indexing of records 2, right? And then I need to actually so records 2 is going to give me, this is the curly brackets, right? That's the content indexing. So I am actually retrieving what? I'm actually retrieving this particular cell array instead of the cell that's wrapping this particular cell array, right? The content of this particular cell is this particular cell array. So if I want to retrieve the content, I have to use the curly brackets, right? And then I need to actually get to the third element of this particular cell array. It's just got one row, right? But I need to get to the third element. Again, I have to use curly brackets in order to actually retrieve the vector, right? If I use smooth parentheses 3, then it's going to retrieve the cell that's wrapping this particular vector with 2 integers, right? So I have to again use curly brackets. Use curly brackets to actually get the 2 integer vector. That's content indexing, right? And then this 2 integer vector is mapped into these 2 integers, right? And that's nested indexing, right? One of the utilities of a cell array is to actually it allows us to actually apply a function to the cells of a cell array. So let's look at some of the interesting things that we can do about the cell array. So one of the things that we can do is to apply a function to the cells of a cell array, right? So suppose the problem that we are trying to solve is actually convert the long name of the weekdays of the days of a week into a short name with just 3 characters, right? So let's try to construct a cell array first. So here I'm going to use content indexing. So days 1 is going to equal to Sunday, right? Days 2 is going to equal to what? Monday, right? And then days 3 is going to equal to Tuesday, and then days 4 is going to equal to Wednesday, right? And then days 5 is going to equal to Thursday, and then days 6 is going to equal to Friday, and then days 7 is going to equal to Saturday. So now we've got a cell array with 7 elements, and the name of the cell array is called days, and the elements inside of this particular cell array are the strings that represents the name of each day in a week, right? So suppose we want to actually shorten the name of a day into like just 3 characters, right? So Sunday has to be converted into like a sun, and then Monday has to be converted into a mon, M-O-N, right? T-U-E-W-E-D, that kind of thing, right? So how can we actually do that using inside of Matlab, right? Matlab actually provides a very interesting function that's called cell fun. Cell fun. If you haven't used it before, it's you can type help cell fun, right? Then it's going to tell you what this function is actually for. Right. So it's going to apply a function to each cell of a cell array. Right. So it's going to take two inputs. The first thing is a function. It's actually a handle to a function. It's a function handle. Right. And then the second input is going to be the cell array. So what Matlab is going to do is that it's going to take every cell inside of the cell array and then use that as the input to this particular function. Right. So basically, it's like applying this particular function to every specific element of that particular cell, right? And you can look at the different options, right? Uniform output, for example, uniform output, a logical value indicating whether or not the outputs of fun can be returned without encapsulating in a cell array. So basically, it's actually specifying if you want the output to be wrapped inside of the cell array or not, right? So if true, which is the default, fun must return scalar values that can be concatenated into an array. If true, the outputs must be of the following types: numeric, logic, char, struct, cell. If false, cell fun returns a cell array, right? So if you set the uniform output to be false, this particular option to be false, then cell fun is going to return a cell array which actually encapsulates the output of the function which is applied on which has been applied on every cell of C, the second input, right? And then it's going to concatenate them into a cell array, right? So depending upon our requirement, we can actually use different options. But here I'm going to set uniform output to false. So I want a cell array as output. So short names is going to equal to cell fun. So I'm going to construct an anonymous function. I'm going to do an anonymous function. So at, right? So it's going to take one input. It's going to take one input, and then it's going to return the first three characters, right? So x is going to be a string, and then I'm going to take the first three characters, right? And that's going to be my output. And then the second input to cell fun is going to be days, right? That's the cell array output, cell array. And then I'm going to set uniform output to false, right? So that's how you actually specify the uniform output option, right? It's like a key value pair. So that's the key of the name of the option is like the key, and then the value is like a false, right? So it's a boolean, right? And then let's just run this. Maybe I should sort of start a new section, right? And then I can just run this particular section. Hold down the control key and press enter. Now I've got my short names, right? Short names, it's not printed because I use the short names, right? So now it's a 1x7 cell array, right? It's a 1, 2, 3, 4, 5, 6, 7 strings, 7 cells basically. It's a cell array with 7 cells, right? And the type of each of the cell is the content of each of the cell is actually a string. And that's one of the interesting things that you can do about do with a cell array, right? And another thing that's used quite widely inside of Matlab is to use cell arrays to actually wrap the options to a particular function or the inputs to a particular function, right? So function, let me start another section called function arguments. So we have been using the plot function quite often to make various kind of two-dimensional plots, right? We haven't actually spent lots of time to talk about two-dimensional and three-dimensional graphics yet. Matlab actually has a very strong capability for making different kinds of graphics, right? But we haven't actually got the time to actually talk about those graphic capability yet, right? But plot is one of those functions, one of those hundreds of functions that allows us to make simple plots, right? Just a two-dimensional plot with two axes, x and y, right? But the plot function usually has lots of options, right? You have to specify what's going to be the line style, what's going to be the marker style, that kind of thing, the color, lots of different kinds of options, right? And one of the ways for actually write clean code is to actually wrap all those options and their values into a cell array. And Matlab actually uses this kind of a syntax quite often in its own internal functions, right? So let's look at an example. So, so let's try to construct a two-dimensional plot first. So x, the horizontal axis is going to be minus pi to pi, right? And then with a stride of pi divided by 10, suppose, right? So it doesn't have to be very, very, very meaningful. And then y just going to equal to tangent of sine x subtract sine of tangent x, right? Some arbitrary function. And then we have to sort of, if we are just doing plot x and y, then we're just gonna use all the default options for the line style, the marker size, marker color, that kind of thing, right? But if we want to specify each of the individual options, we don't really have to actually specify those options inside of this particular function. We can use a cell array to wrap all those options together, and then give the cell array as one of the arguments to the plot function, right? So let's construct a cell array. Let's just call it plot style. And then I'm going to use content indexing. The first row, first column. Let's just call it line width. Right. So how it's going to work, right? It's going to be used column wise, right? So what I was saying is that the options are like a key value pairs, right? The key value pairs. So what I'm going to do is to actually construct a cell array with just the two rows. The top row, the first row, are going to be the name of the options, and then the second row at the corresponding column are going to be the value to those keys, to those option names, right? So plot style, second row, first column. So line width, I want the line width to be 2, for example, right? And then that's for the first column. The first column is just for specifying the line width, right? And then let's do the second column, right? Again, the first row, second column is going to equal to marker edge color. You don't really have to specify them in this particular order, right? You can use the first column to specify marker edge color or marker size, that kind of thing. It can be in kind of a random order. It doesn't really matter too much. All you have to make sure is that the second row actually has a correspondence with the first row, right? The numbers, the values that you specify for those keys must match the corresponding key. So marker edge color is going to be black. Right? And then let's do one more. First row, third column is going to equal to marker face color. And then plot style. Second row, third column is going to equal to let's use green, right? And then all we have to do is to actually one of the things that we have to do is to actually specify the line, right? I'm going to use dash line red dash line that's going to connect the squares, right? And then the last option, the last input is going to be plot style. That's the cell array, right? And then let's hold down the control key and press enter and execute this part of the code, right? It looks like I got something wrong, I guess. Let me pause it. So the reason that I'm getting this particular error is that I forgot to actually unwrap the cell array, right? So Matlab does take does the, what so what Matlab is going to take is actually the content. So the plot function is going to take the content of that particular cell array. It's not going to tell the cell array itself, right? So how do you actually unwrap the content of this particular cell array, right? Again, use cell indexing, use content indexing, but now because we want all the rows and all the columns, right? So we just give it a one colon, which means that we want everything. We want every content inside of that plot style cell array. And then at this point, if we execute this particular line, this section is going to give us the correct plot, right? It's the red dashed lines connecting squares, right? The line width is going to be 2, right? And then the markers are going to have a black edge and a green face. That's going to be the what the figure is going to look like, right? Another very interesting application of cell arrays is to use the cell array to store a set of function handles, right? So you can actually construct a cell array of function handles, right? So let's look at another example. So let's call it cell array of function handles. Right. So function handle is a very useful thing in Matlab that allows us to actually represent any kind of function as any kind of function handle is kind of a data structure for storing the definition of a function, not actually the result of the function output. Right? It's not so function handles are some kind of pointer to a function definition, right? So suppose we come up with a cfun equals 2, so it's gonna be a cell array, right? And then the elements of the cell array are gonna be function handles. So let's just use those trigonometry functions, those built-in trigonometry functions as its elements, right? So sine, cosine, tangent, all those functions are just all those functions are built-in functions, and then we append or prefix all those function names with @ symbol to actually get the function handle. Right? So once we have such a cell array, then we can actually use this particular cell array and use content indexing to actually do some calculations. So suppose we want to compute sine of pi plus cosine of pi over 2. So how are we going to do that, right? So let's just disp, right? Sine pi. So sine pi, that's the first element of cfun, right? Cfun, and then we're going to do content indexing. So to actually get the function handle instead of the cell that's wrapping the function handle, and then we can just call that function, right? So this is actually how we actually call normal function, right? Except now the function name has changed from like sine to cfun1 with the content indexing, right? And then we can just add cfun2, that's the cosine, right? And then cosine pi over 2, right? Let's just run it and see. It's giving us a very small number. That's like close to 0, right? It's close to 0. Is that true? So sine of pi plus cosine of pi over 2, right? That's exactly the same, right? So why do we want to do that, right? Suppose we have a bunch of functions. Suppose we have a bunch of functions that we want to apply to the same kind of data, or different kinds of data. Let's assume it's the same kind of data, right? You want to apply the same different functions to the same data, then, right? Then you can just write a loop, right? You can just put those functions into a cell array, and then just write a loop to loop through every element inside of that function array, and then inside of that cell array, right? And then just just call each of the element of that serial array with this kind of content indexing, and then supply the same input, and then you can sort of get the result of applying all those different functions to the same data, right? That's one of those use cases that we can actually. So in this thing, in this serial fun, we're applying the same function to different elements of the serial array, right? So here it provides us the capability to do just the kind of to do a similar thing. You're applying different functions to the same data, basically, right? So by just writing a simple loop, like for loop or something, right? Let's look at one C fun one, right? Let's just call it F, right? Let's just call it F. Let's do one more example. At this time, I'm going to use anonymous functions, right? Anonymous functions is actually a function handle, right? And then x dot square, right? So I'm actually constructing a anonymous function with the input x, and then the output is just going to be the square of the x, right? And then let's do another anonymous function, y plus 10, right? Looks like I have to actually put a parenthesis around it, so because this comma is treated not just as the end of the function, but also as a separator, right? And then let's do another anonymous function with two inputs, for example, right? And then x dot hat to x squared plus y plus y plus 10, right? And then that's going to be the end of the function, right? And then we can do something that's really interesting, right? Let's do like f1, which is means what? We're actually retrieving this particular anonymous function, which is actually a function that's gonna square the input, right? And then we're gonna supply the input that's 4, right? So 4 squared, that's 16, right? And then let's do f2, that's y plus 10, right? Y plus 10, and then the input is gonna be 7, right? So 7 plus 10, that's 17, right? So it's basically 16 plus 17. Let's see what this thing is gonna display, right? So 33, right? 16 plus 17. 16 plus 17, that's exactly 33, right? So those serial arrays can be a quite useful data structure for storing a collection of function handles, that kind of thing, right? In the next video, we're going to talk about another kind of a heterogeneous data structure provided by Matlab. That's called a struct, right? And then we're going to sort of talk about the differences and connections about the struct between serial arrays and structs, right? And how do we actually convert from between each other, right? So this is the end of this particular video.